Okay, today we're going to be dividing radicals with monomial terms on the bottom. The way you divide radicals isn't really like division, it's more of a process that's called rationalize the denominator. And it's just a process to get rid of the radicals from the bottom of fractions, or from the denominators. Okay, so usually, depending on the situation, if it starts out like this where the whole fraction is underneath... Oh, before I actually go on, as of today, radicals on the bottom parts of fractions, if you leave your final answer like that, it will cause you to lose points. So make sure you use this process to simplify any fractions with radicals on the bottom. Okay, now that I've said that, so example 1, simplify the expression. When we have a radical over a whole fraction, it just means the square root of 54 over the square root of 25. And we're going to try to simplify each radical individually. So 25 factors into 5 and 5. And I'll also do my factor tree for the top right now. So I know it's 9 and 6 for 54. 2 and 3. 3 and 3. So circling my groups, on top, looks like I got a group with 2 3s. So 3 will go to the outside. Square roots of 2 times 3 left over, which is 6. Over. In the bottom, we got a group of 2 5s. Nothing left uncircled, therefore we are done. So yay, we didn't have to rationalize the denominator quite yet, because when we simplified the radical, it went away from the bottom of the fraction. No radicals in the bottom parts of fractions. Number 2, if you look, it already starts off with out a radical around the whole thing. And notice we can't break down 2. Therefore, this is the first example where we'll actually have to use the rationalizing the denominator process. So denominator fractions are not... my words are not coming out right tonight. Radicals are not allowed in the bottom part of the fraction. So what we're going to do to get rid of it is we're going to multiply by 1, but a very special one. We're going to multiply the top and bottom by radical 2, because that's the radical in the bottom. Now I'm multiplying by radical 2 in this particular problem because there's only one term in the bottom. In other cases, I might have to multiply by more than just radical 2. But in this case, radical 2 is enough. And notice radical 2 divided by radical 2 is 1. If I do this, 6 times radical 2 is 6 radical 2. Over radical 2 times radical 2 is radical 4. After you do the multiplication, try to simplify any radicals. 2 and 2. Top one can't be simplified. So it becomes 6 radical 2 over 2. And last step, reduce the fraction if you can. So I can reduce into 3 radical 2. And that's it. 3 radical 2 is the answer. Nothing else can be done. So the next example is another one that starts off with the fraction around the whole thing. So I have to start by breaking it up. So the square root of 343 on top over the square root of 20. Could try to do the factor tree. 4 and 5. 2 and 2. 343. I want to say that's 7, but I'm not 100% sure. So give me a second. Yeah, 7 and 49. And 7 and 7. So circling my groups. On the top, I get 7 radical 7. Over on the bottom, we get 2 radical 5. Now, this time, notice we have a radical left in the bottom. As I said, that is no longer acceptable. So to get rid of the radical in the bottom part of the fraction, we have to rationalize, which means I'm going to multiply by radical 5 over radical 5. I don't have to multiply by the 2 because it's a monomial, and you can, it's just going to give you more work in the long run. So why bother? But I'll do the multiplication. 7 radical 5 times radical 7 radical 7 times radical 5 is 7 radical 35. Over 2 radical 5 times radical 5 is 2 radical 25. Do any factor trees after the multiplication. So 5 and 5, 5 and 7. So I got a group of 2 5s in the bottom. 5 goes to the outside, giving me 10 on the bottom. 7 radical 35 stays the same on top. And lastly, check to see if you can reduce, which you cannot. Therefore, 7 radical 35 over 10 is all I can do. The next one starts off with a radical on top and bottom, so I have to rewrite it here. So the square root of 9 over the square root of 12x squared. If I simplify this, the square root of 9 I know is 3. Now I'm going to do a factor tree for that. 4 and 3, 2 and 2, x and x. So on the bottom, we move to the outside. 2x, square roots of 3 left over. I can't have a radical in the bottom, so I need to multiply by the square root of 3 over the square root of 3. When I do that on the top, 3 times the square root of 3 is just 3 square roots of 3. On the bottom, I get 2x square roots of... Okay. Do your factor trees, or simplify the radicals. So we get 3 radical 3. To the outside, I'll move a 3, so I get 6x, nothing left on the inside. And then last step, see if you can reduce. 3 and 6 reduce to make the square root of 3 over 2x as the final answer. And then we have one more problem here. Simplify the expression. So again, there's a radical around the whole thing, so I have to break that down first. 27y to the third over 8x, the square root of 8x. If I break that down, 27's factors are 3 and 9, 3 and 3. And then 8's factors, I'll do it in a different color here. 2 and 4 and 2 and 2. So when I simplify the radical, I get on top 3y, square roots of 3y. And on the bottom, 2 square roots of, looks like 2x. Well, we're not satisfied if there's a radical on the bottom, so I'm going to multiply by that radical, which is the square root of 2x. So square root of 2x on top and bottom. That's going to give me on top 3y, square roots of 3y, times the square root of 2x is 3y, square roots of 6xy, over 2 square roots of 2x times 2x is 2 square roots of 4x squared. Now I know I can't simplify the top radical. 6's only factors are 2 and 3, so I can't get a group of 2's out. But on the bottom, I can. So I have to simplify that radical. So it gives me 3y, square roots of 6xy, over 2 goes to the outside, so that gives us a total of 4 there. X also goes to the outside, nothing left on the inside. Lastly, check to see if you can reduce. However, nothing goes into both of these. Therefore, this is the final answer.